Question 3. Free kick from a point O. 2 seconds later, we know exactly where it is in the sky. Great, sketch it. Starts from origin, parabolic path, passes through some point. It could be that that point is on this side of, before it gets to the top, we don't know. But if you're kicking a ball and it's gone 22 metres already, chances are it's probably on its down slope, not that it matters. So stick your coordinates on there. Now, initial speed, let's call it u, and therefore the components of that will be u cos theta and u sine theta vertically. Those are going to be what we need to use. So set up your suva. We know we want it to be 22 along and 2.4 up. We have expressions for the components of initial velocity. We have gravity. This time we know t to be 2. Okay. S equals ut plus a half at squared. Stick everything in. Quite a big expression there, but just needs simplifying. So the top row of that equation reads 22 equals 2u cos theta. Now just because I can instantly, let's just simplify that to 11 equals u cos theta divided by 2. The second equation, 2.4, equals 2u sine theta minus 19.6. That's come from here. 2.4 equals u sine theta times 2, which is our 2u sine theta. And if you calculate what's going on here, you've got a half times 2 squared times negative 9.8, which gives us the 19.6. Okay, the top of these two equations here can be rearranged to make u the subject. And the second equation can receive that result. Oops. Like that. Obviously I need to subtract the 19.6 still, but before I go any further, I'm actually just going to simplify that. Notice we've got a 2 times 11, and we've got a sine theta divided by cos theta. So that's 22 and tan theta. Great. One equation, one unknown, rearrange to get tan theta, and actually, nicely, you get exactly 1, and therefore theta is 45 degrees. We need u as well, because the question asks for the velocity, which has magnitude and direction. We know the direction now, and substitute that in here to get simply u equals, this one here, u equals 11 divided by cos 45, which works out to be exactly 11 root 2 meters per second. So you could give your answer like that, but even better, let's substitute those values into here. This is what it asked for, wasn't it? And we might as well give it as a vector. So using your new u and theta, calculate these, and lo and behold, you find that u cos theta with these two values is exactly 11. Simplifies to 11. And u sine theta also just 11. So there's a very nice, straightforward, simple version of the answer to part 1. Okay, to find the maximum height, let's tell you what, let's over here notice that I'm going to replace this u sine theta and u cos theta now with 11. You shouldn't do this in your exam, you should draw new diagrams. I'm just trying to recycle so I can use the space. At the top here, that's what we need to think about. Now we don't know either of those coordinates here, so we can't do what we did here with the 22, 2.4. But what do we know is true at the maximum point? And if you draw a tangent there, it would be horizontal, 0 gradient. In other words, there's 0 component for the y. There's 0 y component of the velocity at this maximum point. So, Suvat. Now, our initial velocity is 1111. Our final velocity is 11.0. So remember, we're not actually going to need to bother knowing. We're not going to need to know that this is 11. You could put blank 0, because crucially it's the 0 there that we're interested in. But as we know, the horizontal component of velocity doesn't change, because the only force acting on the particle is gravity, which pulls down, which is perfectly perpendicular to the horizontal direction. It can't change its horizontal speed in this model. So just put 11 there. Acceleration is gravity is normal. Time, just t at the moment. But just pretend that we don't know that for a moment. We're trying to find s. We don't care about t really. We know a, we know v, we know u, we want to find s. So normally you'd want to use v squared equals u squared plus 2as. But in 2D, that equation is not available to you. At least not in A-level maths. So we're going to have to go via t. So we're going to need to use two Suvat equations. So let's first use v equals u plus at and work out what t is. Substitute things in. Now notice that when we do that, our top equation is just 11 equals 11 plus 0, which doesn't tell us anything new. So that's irrelevant anyway. So we're only interested in the y component, which gives us a useful equation, 0 equals 11 minus 9.8t, which gives us t equals 55/49, or I've done that thing again. 55/49, which works out to be roughly 1.122 seconds. And then let's go back to our old friend s equals ut plus half at squared. Knowing our new value of t, this becomes quite awkward, but it's just long. U is that, t is that. Bang everything in. Now, I know we're only interested in the maximum height, so we're only interested really in the y component, this bottom row. But do both. That's a big tip from me to you. Do both. Because when you come to part 3, you're going to need to know the x component anyway. So do both at the same time. It's more efficient in the long run. Calculate both components and we get 12.35 and 6.17. It's measured in meters, and that gives us the coordinates of our highest point here. So to answer the question, the maximum height that it achieved is just the y coordinate, sorry, the y component, 6.15 meters. Okay, great. Seems reasonable as well, doesn't it? Part 3, really easy, because we just need to spot that this is a symmetrical curve, especially because we start and end at the same height. We can assume that it's perfectly symmetrical. So if we've gone along this distance here, 12.35, to get to the highest point, we must do that again to get to the range. So our range is simply 2 times 12.35, which just gives us 24.7 meters.